ProLytX to talk through automated SIS testing. Basically, less time, less people, more compliant. I've got with me David Wicker and Brian Bailey, who have years of experience in SIS testing. They've been through the traditional testing methods, been out and tested hundreds of SIS systems, and now are doing that in a more innovative fashion here with ProLytX. And so go ahead and give a quick intro again, Dave.
Sure. Hi, I'm David Wicker. I'm our technical director in charge of our technology development. I've got 16 years in the industry doing SIS configuration and testing.
I'm Brian Bailey. I'm a functional safety services director. I've got 15 years or so of experience. Majority of that has been focused on functional safety, whether it's SRS writing, auditing, testing, the whole span of that.
Okay, excellent. So we're going to talk through three basic subjects. What are the challenges that the industry is facing? What is our solution? And what are the results from that? So as we dive into this, we'll go through these four primary industry challenges: cost, documentation, repeatability, and quality. So can you guys speak a little bit to the cost aspect of what the pain points are in the industry right now?
Sure. There's really three components to the cost. There's the cost to do the initial implementation or develop test procedures to execute a test. The second portion is actual execution time and execution resources to perform the test. That's where we see most of the cost, actually. And then there's maintenance, long-term maintenance of that procedure. So whenever you have a future outage, you need to kind of dust it off and re-execute that test. And there's costs associated with updating it for any MOCs, any changes that have been done since the last time you executed the test.
Okay, so I think when you think cost, it's real easy to think about time during the turnaround, how many people, how many days. Mm-hmm. That's what everybody probably comes to mind first. But you're also describing the original procedure creation itself, and then what do you get for that, right? What do you get for all of that funding that you have to do to write those procedures? Then you still go through a rather sometimes tedious test, and then you have the recurring cost of keeping up with the documentation and retesting the future, right?
Yes.
Okay, so it's multifaceted, but you're going to really focus on, and we will focus later in our savings, have a lot to do with time during that shutdown.
That's
right? Okay, and then we've got an issue with documentation. What are we seeing there?
So documentation, we see everything from extremely good procedures, which are well written. The problem with extremely good procedures, they tend to be pretty voluminous. You get to 1,000-page procedures that they do a good job of covering it, but then you get into the problem David just talked about, where you can't really keep them up to date easily. It's hard to take this 10,000-page Word document and keep it up to date with what you're actually doing in your system, unless your system is frozen. And we all know that no system is ever really frozen until the plant is retired. So as an auditor, if I see a document that's only 2 or 3 pages, I probably know that either I can't tell what you did, which is more than likely even if you did a good test, or you really didn't do a good test. So managing that documentation that goes with that, keeping it up to date, is all a very big challenge.
What about the actual documentation of the actions during the test, though?
So that's the thing. If you have a good procedure, it's going to be very long, and it might have a lot of checkboxes to show what you've done, but it's hard to follow. It's as an auditor, I can look there. I might be able to see what you did, but it may take me 6 months to figure out how well it was done.
So is that typically documented with highlights and initials?
Yeah. So a quick test would sometimes might be done with just a highlighter and a cause and effect, which is can be varying degrees of quality. You're going to depend more on your people than your procedure in that case. You have a senior guy that may come in and do a test it with the cause and effect and do a great job, made better than their best written procedure ever. But if you have a junior guy that has to come in and do the same thing, he's going to miss things, not through no fault of his own. He just doesn't have the experience or the background.
Okay, but essentially that highlighting or initialing is pretty much the only record you have of that activity, right?
In those cases, that's true. And as an auditor, I can't tell who did that, what quality it was done, and if I had to audit you, it wouldn't be good, because I'd have to see what you did.
Okay, and then we've got the question of repeatability. I think you touched on that a little bit, Dave, but talk about that. So.
Yeah, so the difficulty, if you don't have a fully documented procedure with every step laid out, is that you could give it to person A and person B, and they're going to execute that test in a completely different way. So that calls into question exactly what you are doing and if you're actually testing it right. For example, we see routinely a single step in a test procedure that says, restart boiler. Well, there might be 100 things you have to do to actually accomplish that task. So if it's not completely laid out and documented, this is exactly what you do, you're going to get variations in the way you actually perform that test.
Okay. And then we've got one more listed here, which is just the overall quality of the test. Can you guys talk to that a little bit?
So the quality of the test, if it's not well documented, it's going to rely on the individual, and I already touched on that a little bit. One of the other things, the quality of the test is, if it's a good test, it's going to be pretty long, and it will discover things that should have been or could have been missed. So
What about, so if you're testing, what I'm thinking is all the permutations of what can happen, all the what ifs in the SIS world. You've got to take that input device and test it for its faults, test it for its 2 out of 3 in some instances. You've got the various scenarios. Do these tests always really cover all of those scenarios when you're doing them manually?
So what we see routinely is our clients will, in a traditional method, they'll do a function block test first to fully test out how their blocks work. And then when they're doing an FAT on the initial stages of the project, they'll do a more thorough test. But then when it comes time to actually test this on a routine basis during the entire life cycle of the SIS, it's a much slimmed down version that does not go through those voting combinations, checking of bypass handling, bad PV processing, or even sometimes the permissive or startup logic. A lot of times, just out of the necessity of reduction of the test for time purposes, those things get lost.
Well, and that reduction is the pressure being critical path in some of these instances. Is that right?
Absolutely.
And the other thing about that is, even though you have a plan up front, you've tested that function block or the way that code's supposed to be written. Have we seen scenarios where code was multiplied and it wasn't multiplied consistently? So you've got little inequities in the way that's built?
Yeah, you can see it on the code side. You can also see it on the procedure side, especially when you're managing these procedures by hand. You may have one procedure that is well done. You make a copy of it. You forget to update the copies. You have a lot of that in the industry.
That really plays back into the cost and the maintenance of these procedures, because when you handle it in a traditional way, you're doing it manually with maybe a Word document or Excel file. It's difficult to keep that up to date.
Okay, so we've talked about some of the primary challenges that we see when we go out and talk to prospective clients, when we look at folks that are needing our services. And so cost, documentation, repeatability, quality. But do you guys have like some experiences, a particular instance you can share that will kind of bring that to light?
Yeah, so I've got a good one. Years ago, we did a large SIS migration project, and due to the cost, the project was thinking about, oh, I don't really want to spend the money to develop detailed test procedures. So they decided to walk through the cause and effects, do a very well-tested, well-structured test, but there was no official documentation. We literally highlighted the cause and effect as we went. So even though we did a good test, we couldn't really prove it. So fast forward a few years, we did an expansion to the same facility, and the project in the future decided, well, I cannot prove that you actually tested the original system. So you're going to have to go through and back document, create test procedures for the entire facility, and re-execute all of that test, not just the portion that you're adding.
So that ended up costing, you had a test that was done, fully done, but it wasn't documented, it wasn't repeatable, and really you don't know about the quality necessarily because you couldn't prove it.
You couldn't prove it, right?
And so essentially that cost more to go back and do that and go through that. Whereas if you had an actual documented repeatable test, then you could have saved quite a bit.
That's right.
Okay. Did you guys want to add anything more to the challenges that we're seeing in the industry? Okay. Well, that's a real good start. So that's the first piece. And for anyone who might have joined late, I mean, basically we wanted to set the table for what problem are we solving? What is our company doing? What's our role in the industry? And as we go out and do SIS systems, this is what we're seeing. This is the pain points, the frustrations that our clients are seeing. They're looking for a solution that's not just more man hours and more effort. They're looking for something that's a real transformation of this process into a more innovative solution. So I'm going to flip the slide real quick, and we're going to talk a little bit about our actual solution to this, right? Okay, great. All right, David, can you tell me a little bit about what ProLytX is doing to solve this?
Yeah, so really, before we started ProLytX, I had 10, 11 years in the industry where I was very frustrated doing countless number of FATs, doing it the traditional way, and I just was thinking there's got to be a better way to handle this. You're writing a very long-winded Word documentation for the procedure. It takes a long time, and then you're also having to develop a mechanism to make the test run efficiently. And then we experienced problems like, okay, you're rushing to get ready for an FAT on a project, and it's not easy to test. So what we wanted to do was create a solution that would both make that procedure generation easier and also the test execution in the same tool. So that really could combine those efforts and then provide a mechanism for long-term management of the system. So what we did is you're going to start with the same design documents that you would start with for configuration of an SIS, right?
So these are your cause and effects,
Cause and
your
effects,
IO list.
SRS, any narratives, everything that defines how the system is supposed to work. We take those and we produce test procedures with our software. So ProLytX TestDrive is our solution. It's an SIS validation software that is procedure based. So it provides a mechanism for you to actually create a structured test procedure. But not only that, spit that out as a document, it can also execute that in a variety of modes.
So instead of taking these design docs, writing a Word procedure, and then manually testing this device,
Right.
what you're saying is that building that into the software package. So you've got a simulation of what the logic needs to do, or a driving tool for what the logic needs to do, that spits out a procedure as a result. So you've got a very precise procedure that didn't take forever to write.
Right.
And it wasn't written in an English book format, right? In a Word format, but more of a mathematical type format, which is really what you're talking about. And then we're able to drive the SIS and test all the permutations.
That's right. So we actively communicate two ways with the SIS. So what we do is write the test procedure such that the inputs are overridden and we force values in, and we're constantly monitoring all of the tags in the system. So we have expected results as you go through the procedure. Each step has actions and results. So the software is constantly monitoring those, and then when you execute a step, can record whether or not it was pass or fail with the timestamp, and every change that happened in the system as a result. All of that gets documented. So we output that as a procedure, both before you run the test and after. We include embedded test results with timestamp information. And we also produce a full test report with an audit trail, a full log of everything that occurred while you ran that test.
So I'm gonna follow up on that just a little bit. You've got the SIS here with the logic that was built by the integrator. So we're not proposing that we don't have to write this logic. This is coming in as a third party.
That's right.
To test that logic, independent of the integrator, right? And you said something about monitoring all outputs. So let's say you've got a system with 100 IO points, 100 outputs. Well, you trigger one change and actually monitor all 100. You know what you're expecting to get. And the pass-fail is not only did the valve close that I wanted to close, but did anything else happen in the system that wasn't intended to happen? Is that correct?
That's exactly right. And because we're doing this with a computer and it's in simulation, we have those kind of capabilities. Whereas a standard procedure, you might be only checking the 3 or 4 things on a stiff that you're expecting to occur. We can actually check the entire list of outputs for a facility. We can get everything up and running and healthy, trip a portion of it, and check to make sure it did not cause a trip of a portion of the facility that was not supposed to trip.
Okay. And then this procedure replaces, so are these procedures comparable and equal to what you would produce if you were contracted to just write a Word document procedure?
Definitely, and there's a variety of formats that we can export these in, and we can tailor those to specific client requirements, and we do that. The main difference is they are much more thorough. So we prefer to do electronic documentation. We do print it out sometimes, but because of the nature of how much we're testing here and our capabilities, they end up being longer. So we can go through, like you mentioned before, various voting combinations. We can do the detailed checks of bypass and bad PV handling. and different combinations that normally you would try to remove from the test to save time. We can perform all those because we can do it so much faster.
Right, and because it's digital, because you've transformed it digitally, you're actually kind of raising yourself up to a higher level to be able to look over the entire processor, right?
Yes.
And then, the key thing here, test reports, we had a pain point on documentation of what happened. But here we're actually recording all of the output changes, everything that's happening in that controller, right? So you're able to report that out and validate. When you go back and look at that historically, what are you seeing when you're looking at that report?
So you're seeing step by step what was defined for the test procedure. You're seeing what occurred, what you forced into the system, and what the expected results were, and you can see the actual results and with actual values. And then in addition to that, you're seeing any steps that you did manually. So if you were to stop the structured test and do something manually in the system, that also gets recorded and embedded within the test log.
Okay, so we're going to get into some of the features,
Mhm.
a little bit about the way that works and what we're talking about here. So this is a great overview of what we were trying to accomplish. Now, I guess at that point, are you guys ready to dive into some of the real features?
Yes.
I think one of the ones you just mentioned was presets for startup sequences and status. Talk a little bit more about that.
So anyone that's performed an FAT has had the struggle of, overriding, forcing values in for 100, 200 or more tags just to get the system healthy to do a reset. So we have that capability. We call it presets. You can give a name and a list of tags and the values, where at a click of a button, you can set up hundreds of tags to a known value. So this is very useful for setting a system up to known healthy pre-start conditions, then walking through a startup sequence, or returning back to that known state in between trips. Um,
And that really helps then when you start talking about the permutations of logic. How many ways am I going to test, this particular input device? The not having those presets sort of pushes you to skip some of those steps or potentially not want to test it as thoroughly, I'm assuming. Is that correct?
That's right. And those presets can be embedded within the actual test procedure, which also saves some space because you define it once, it's a list associated with your test procedure document, and then it's referenced on the step as something that gets activated. So you don't have to put those 100 or 200 tags in your procedure body.
Okay, excellent. Okay, that's great. Now tell me a little bit about how this thing operates. I mean, you clicking through each of these steps, or what are the options to really run a test?
So really, based on our experience, we needed the system to be very flexible, all the way from full manual control, one tag at a time, to semi-automated to even fully automated, click one button and get a test report after X number of hours. So really, we've built all of those different execution modes into TestDrive. Typically, before we run a structured test with a client for their witness, we will run in fully automated mode several times to work out and debug any issues that are there in the procedure or in the logic to get everything healthy, work out any issues in the logic with the system configurator. Then when it comes time to actually witness the test, we run in more of a semi-automated mode where portions of the test we can run fully auto if they've already been witnessed, or we can step through in a very quick semi-automated way. Everything's preloaded. You just have to click the step whenever you're ready to witness the next portion of the test.
Okay, so we've talking about transforming a test into a package that can handle everything from the procedure to the reporting to the actual logic simulation. What does that look like in the end? Like, what are some examples in terms of size or time frame that we're talking about with some of these tests?
So I would say an average system takes about 10 hours if you're going to run it in a fully automated fashion. That might be like a mid-sized boiler with a startup sequence and permissive logic that you need to check. If it's something that is more straightforward, no startup sequence, cause and effect type logic, you're looking at 2 to 3 hours on average to run a fully automated test. And we've had tests that run all the way up to 30, 35 hours in length on a fully automated run. Now, if you were going to step through that same procedure in a semi-automated fashion with TestDrive, it'd take about 4 times longer. And if if you're comparing this with simulation versus what you would do with manual traditional methods, it's about a 10 times, an order of magnitude time savings on execution time.
So that 35-hour test, you say that's maybe a week's worth of testing. If you're sitting there and you're doing the semi-automatic, you're doing a batch of logic, you're talking it through, you're checking it, and then you say if you're going traditional methods, just old school forcing, you're talking weeks to run that test. Is that right?
That 35-hour test would take at least 3 weeks, I would estimate, if you were moving pretty quickly using manual traditional methods.
And we've had real world scenarios where we can show and we have credit from the client for that accomplishment of shrinking that time. Is that correct?
Definitely. So we're able to test a much more thorough test, right? It's a much longer test procedure, but we can do it in a much faster time. So we don't have to sacrifice the quality of the test itself.
Okay, fantastic. Do we have some simulation that goes along in this process? What about motor run statuses, limit switches, little things that need to happen?
Exactly, yeah. So to make this work and to make an offline test really function, we needed a lot of what we've coined a low fidelity process simulator. We didn't want to model the whole process. We're not targeting that. What we're trying to do is show that the SIS works, and to show the SIS works, you need exactly what you said: limit switch feedback. You may need to run a flow whenever there's a valve open. Basic motor run statuses, that sort of thing. So to do that, we built in a low fidelity process simulator, and we can turn these on and off. So that gives you the ability to use the same test on the live system or the offline system. So one of our biggest targets is an offline system. We want to do this testing in parts, do as much testing as we can offline, take credit for it, and then do whatever you need to online to satisfy your own requirements.
Okay, great. Well, thanks for that. And then, as we look at this, one thing I noticed is that, if you're in the safety system industry, you've come across various vendors, whether that's Triconix or Yokogawa or Honeywell or Allen Bradley, they have their own styles of programming and interface, and maybe even in the way that tested. And so what I see here, though, is just a generic SIS. So is this dependent upon a particular vendor?
No, we actually designed TestDrive with that in mind. We wanted to be 100% vendor independent. The test writing portion of TestDrive is not restricted to a particular vendor, and the driver portion of TestDrive is swappable. So you can swap one driver, say for a Yokogawa system, for an Allen Bradley system, just swap it out. You can potentially use the same test. All you have to do is retag it. Tags, of course, are different between systems. You guys should all know that. But yeah, the idea is we're vendor independent. We support tons of vendors. We've got all the Allen Bradley processors, Yokogawa, Honeywell, Triconix, and the emulators for Triconix. Just the whole list. We're working on more pretty much every day.
Not only that, we built it with the ability to swap dynamically between hardware mode and an emulator or simulator mode. So you could take the exact same test configuration, run it against an emulator or a simulator, depending on the platform, or you could take that test and swap it over and communicate with real life physical hardware, either on a development environment offline or even with the real life production equipment. And we do all variations of that.
Okay. One other thing I wanted to ask is, do you need to see the logic in order to do TestDrive? Do you need to have access to that, or are you able to build this straight off of the design doc so that's an independent an audit basically of what the integrator has written?
So the test procedures themselves are developed solely off the design documents. We don't bias it on anything that's actually been programmed. The final step to finish the configuration, to finish the simulation piece, is filling in the tag names from the actual program. So at the final implementation of a TestDrive project, that's where we take the actual configuration file. TestDrive automatically imports all of the tag information from the configuration, and then we associate that with the variables that we've defined within our tests.
Okay, and that's a pretty important breaking point in the industry too, to get the good test that you need, right? From your, Brian, with your qualifications and auditing responsibilities, that's one of the things that we're looking for, right?
Yeah, one of the biggest breakdowns we see from a technical side is a lot of times the guy that wrote the program will do the test, and through actual problems or just not knowing what to check because he wrote it, he may miss things. And having that independence where one group develops the test procedure and one group develops the actual logic is much better.
Okay. Well, then the last thing from a technical standpoint, because this sounds like an innovative solution and a step forward for the industry. What else is what are the competition to this, and how do we stack up in that case?
So our main competition is going to be Triconic Safety Validator. They're doing something similar for Triconics only. So they're limited on the systems they approach. We've already discussed a little bit the vendor independence. They also have a little bit different test structure. Getting their procedures, from what I understand, is quite a bit different. And we've taken a way to be more flexible, providing procedures and data and taking design documents into our system. Another competitor we have is Cape. Cape is targeted more at operator training and full-on process simulation. We're not trying to do that. We want just enough to test the SIS. We want to show you what you had. We want to make it very easy to audit, easy to read, easy to follow test procedure. We have quite a bit of strength there versus Cape.
Being procedure driven is a differentiator
Yes.
there. So the multi-vendor scenario is a key driver.
Yes.
And being really procedure driven. The other thing I think we didn't mention is, what does this look like when you go to test? Is there a graphical interface? Are you able to really, get a feeling for what's happening during the test? I've seen some of these that are more script based. They're very, mechanical. But what does this look like on the console when you're working with it?
That's a good question. So we would typically go to a site and do a full software demonstration for a client that's interested. But if I were to describe it, we do have a full graphics interface. So we call them dashboards. It's almost like a little simulation sandbox for you to drag and drop tags with pre-configured shapes. That'll not let you not only witness what's going on in a simulation environment, but you can also take manual control of any of the tags from those screens.
Can I create a cause and effect type view where I can see an animated cause and effect during my test?
Absolutely, we do that usually as just part of our own internal testing.
So for the manual side, I can build out input devices, cause and effects. I could actually click through that and manually force the bit. So it's not just like a tag name based list.
One thing we find helpful is we'll build, if you have a boiler, for example, we'll build a startup panel with buttons like switches and lamps that emulates what you might see out in the field. So you could sit there as an operator and then walk through a startup sequence. The system itself is running the process simulation. So you could actually hit, start purge, start pilot, start main, and the system would respond just as it would in real life.
So one of the main things we see here with clients is due to the speed, we can run through the structured part of the test. Like we said, we can take a 2-week test or 3-week test and shorten it to a couple days. If you can run through that structured portion, you still have days in your FAT a lot of times if you've allotted a bigger portion. You can take that, you can run from these graphic pages, startup pages, you can run through all these different scenarios you wanted to test, one-off scenarios or whatever. You may find new things that weren't even part of the structured test that you wanted to test, and usually you prove that they work, but occasionally you may find a new error that you need to address, or a new set of operator-driven requirements that even need to be applied.
Okay, so because I think when you talk competition out there, I think that graphical interface is a real differentiator also. And so as we look at this, in summary, like from a technical highlight standpoint, this is the solution. This is procedure-driven testing with full logging of all the activities and interaction with the SIS. And this is then saved and repeatable for the future, correct? Right. Okay, so you're testing it, you're covering the problems that we talked about earlier in terms of, and we'll get a little bit into the savings from this, but we've got a quicker execution, we've got the repeatable process, we've got documentation, and we've got a thorough test.
And one added benefit that we're seeing our clients use is because it's fully vetted, you've gone through the test initially. Now for the life cycle of that system, anytime you make a minor change, you can run a full test of the entire system in an automated fashion with a single click to verify that you did not break something else in the system.
Right, okay, so
say like a set point change, right? No one today using traditional methods is going to repeat an entire logic test. But that's a very simple thing for us to do once we have the system configured.
Right, excellent. Okay, well then that covers kind of part 2. What did we do, right? And now the question is, what's the result from that? Like, what do we gain? What are our clients gaining from that? And our tagline for this webinar that Trey so graciously put up earlier when we got started was less time, less people, and more compliant. So, I mean, this is what everybody tuned in for. This is what, hopefully we've got influencers on the line that we can give them ammunition to improve their company and to improve their processes, help them digitally transform. But why? What do we get from it?
So what we're seeing with our clients is they're getting an immediate payback in their investment in TestDrive from the very first implementation. So heavily targeting, say you have an outage, it's required to test your safety system as part of that outage. So we go in prior to that outage, develop the system in TestDrive, run full logic tests, and we're seeing dramatic reductions in the time to actually execute. We're seeing reductions in turnaround schedules, and we're seeing reductions in the number of resources required to execute a test.
Well, let me ask you something. You started this earlier talking about your pain points programming as a FATs and I think in the origin of this idea, we had a lot of thoughts about just testing programs in the shop, right? In the fat, doing better tests, kind of altruistically. I would like a better test because poor test. But what did we find? Our clients came back and said, hey, what about the use of this during the time where it's most valuable to me? Is that right?
That's right. So our initial focus was heavily FAT because that was our mindset, that was our experience. And very early on, our clients told us, that's great, we see the savings there, but there's huge savings to be had on reducing our turnaround test execution time. It typically falls at the end of a turnaround, and it's in the critical path. So every bit of time you save there is real money to those clients.
Right. So we can talk about ones and zeros and bits and procedures all day long, but ultimately, when you got less shifts and less people showing up to that shift, that's critical, right?
Yes, and we've had confirmations from our clients anywhere from 1 to 10 shifts that have been shaved off an entire outage, and a reduction
10
in
shifts?
10 shifts, yeah, 5 days. And we've had reduction in personnel required to execute tests up to maybe about a dozen people.
So we had, I think you shared in preparation, staffs that were 15 techs that were involved in a test, all the moving pieces, all the presetting, all the witnessing and monitoring, the highlighters that we're burning through. Those are minimal cost, but they're in there. Throw them in there. So you're saying like 15 people, and then what did they run that test with?
With just a couple engineers
Just
running TestDrive, and then a few people out in the field doing field validation.
So 15 down to 2 was a real world example of where we used less people.
Right, because instead of sending an army of field technicians out to drive all the transmitters and set up the test, the software is doing all of that. You need people in the field. If you're in an outage, you need people in the field to confirm the final elements, right, to make sure those are working properly.
Visual inspections.
Visual inspections, but all the hard work is being driven by the software, and allows the testing team that's responsible for validating the system more brain power to sit and focus on what the system is doing versus focusing on the logistics of actually executing that test.
Well, and you didn't, so on the time, can you give some quantity on what the time would be?
So there we've had confirmed savings from our clients. I mentioned anywhere from 1 to 10 shifts. So that in real life time, that's 12 hours up to 5 days worth of time off an entire turnaround schedule.
So saving 10 shifts. And forgive me, my writing was better when I had more time. And here, 15 people down to 2. So have we had clients quantify what that value really was to them?
Yes, they have. The typical number people use in industry, depending on the size of the facility, is roughly $1 million a day when they're in an outage. Obviously, right now is a difficult time, but everyone is focused on cost savings. So this has been a huge focus for us.
So simple math says 10 shifts is 5 days, and 5 times 1 is 5. 5 times 1 million is $5 million, is that what you're saying?
That's right. We've actually had that confirmed from our clients.
So we didn't create that number.
No.
That number came in an email from a client. Okay, awesome. Man, okay, well then, let's not forget compliance.
More compliant.
CFSE, share
So-
with me some compliance.
There's a couple parts to compliance. Number one is auditability. That one's very easy. The report we generate is very easy to audit. It says it's got the procedure defined in it. The client has agreed to the procedure, and it's got a very easy yes or no. I passed this step of the procedure. Once that procedure is written, TestDrive will make a result that I can audit in a number of minutes. Just look at the summary, say everything passed or everything failed or whatever didn't pass. What was the issue?
What about scenarios where we have seen that previous test missed something?
So the second part of compliance is actually quality of the test, quality of the result. Our tests we generate are very structured. We work with our clients to make sure they cover all their requirements, whether they're technical requirements or other requirements. And we've had several cases where we've gone in and we've got running systems we're doing a test on. We find issues, right? So in some cases, these have been systems that have been in operation 15 years. And luckily, it was never tested, but there were cases where we found issues where a combination of events would have caused a miss, basically.
So the design documents clearly defined a scenario that had an engineered safety risk.
Right.
The traditional testing methods weren't catching it,
Right.
because of the complexity of that. But then our software going through and really interpreting those design docs, putting all those conditions electronically, digitally, caught those problems that hadn't been caught in a running system, which was just lying in wait potentially for an actual safety event.
Right, and this is a systematic error, which is something we catch a lot more often than I've seen anyone else catch. Systematic errors are ones where the user basically thinks it's working, but it's not designed right. So the logic is not designed right. We apply this rigorous testing scenario to it. You can find those errors a lot easier.
And to be honest, we don't care how it's programmed. We just care about the results.
We don't,
right? So this
right.
isn't we can build a better function block
Right.
or ladder logic in my favorite case, but I don't know if anybody even uses that anymore. But
Yes, they do.
they do? Awesome.
Oh yeah.
So it's about finding something that's been buried that just wasn't thorough enough.
And over the last few years, we've done over 150 different SIS platforms and different processors. And I can easily say that not a single one of those has gone by without us finding something. These are systems, in most cases, these are systems that are already in service, and we're finding.
Or any of those systems that you originally did in your
Those were not ones I originally did. No.
Okay. Just a question.
One other advantage of this that we haven't really talked about on the more compliant issue is a lot of the times we do find issues that for instance, we find an X that is happening on the cause and effect that isn't showing the cause and effect.
So there's an improvement in the documentation
Right.
through this process too,
Right,
because you're not only auditing that SIS, but you're auditing the way that the documents come together to create the narrative that you're trying
Right.
to get to, right?
and in some cases the logic may be what is intended, what is wanted, but it may be either missed the MOC, they forgot to do the cause and effect, or maybe it was done, in the FAT and no one ever thought to even do an MOC for it. It just needed to be done, got done in the logic, so it was working correctly, but no one ever updated documentation. So since we're taking the design documents, we're testing the logic. At the end, they have to match.
Okay. And there's more to that. There's the evergreen nature of this data, the software, and that would be something that we could talk individually with our viewers on about that. But the thing I want before we move on is what you just, it's easy to equate money to how many people have showed up at the turnaround and how much faster you get back online. How do you equate money to a safety event that is prevented?
Well, yeah, there's no real way to do that, right? Because you're potentially saving lives.
So the biggest value might even be there.
Right.
It's one we can't put a number on, but I mean, it has huge value.
Right.
Okay. Well, I think that covers the three real subjects that we wanted to discuss. And really, we've covered the cost aspect, the quality, the repeatability, all of those things, and really shown how that results, how ProLytX TestDrive is resulting in less time, less people, more compliance, really a better solution. And I think now Trey, we had just some questions potentially from the audience that we may want to go to as we go through the last few minutes of this. Is that correct?
You bet. If there's any other questions, please just type into the chat window. We appreciate it. But one came in, do I have to run this on my production system?
So no, so I mentioned before that we can actually run in both an emulator, simulator mode, or on physical hardware. So some of the testing that we do is on a live production system, especially for facilitating I/O loop checks. But most of the time we recommend that you run this offline. So we recommend in what's called segmented testing. So you could take the logic validation out of, say, an outage. You don't have to perform the logic validation on your actual production system. A lot of our clients have offline, non-production development systems as well. So it is preferred to run these tests on physical hardware. That way you're assured that it's running exactly the same way it's going to run in real life. But we have the flexibility of connecting with emulator, simulator, physical hardware, development hardware, or physical production hardware as needed.
Okay. And then a couple of people ask, how much does this cost?
So cost is going to be a little dependent on the client. Typically, we like to go out, we'll do a full demo for you, and then help you pick a small project to try this on, basically to prove the point. We want to make sure you understand what we're offering. The main factors for cost are going to be the size of the system, the complexity of the system, and then your internal requirements, like what all your requirements are and what kind of reporting you need to see to make sure we can cover all your required scenarios. Yeah, that's about it.
All right, that's all the questions so far. If you guys have any questions, please type them in. You guys want to wrap up with any final thoughts?
Well, I'd just like to say, thank you guys for taking time out. I think our intro got, potentially we had some audio issues there, but we wanted to say thank you for accepting a WebEx that you didn't have to, and joining us for this discussion. We're really quite excited about the successes that we've had, as David mentioned, testing over 150 safety systems, getting out there and working with multiple organizations where we can help really enable a change, a digital transformation for them in a process that's really been, it's a long-standing SIS testing process. Kind of, it needs this new method, and we really feel like we've got the track record to do it. So I think, Trey, what we wanted to say is we're available also for further conversation, as Brian kind of mentioned, and David. We would come and gladly come and do a demonstration or have a particular isolated WebEx for any of our participants that would like to do that. You have Trey's email address, so you can just respond to him and let him know what any further questions you may have or request for a meeting. We could even meet this afternoon if you wanted. And then depending on the pandemic, we would be more than willing to come out to your facility when able, to actually bring a demo kit and a PLC and a graphics engine and show you how this works. And I think Brian mentioned too that, our starting point is usually just a small system. I mean, we start with systems 50 IO, 100 IO, a small compressor or something of that nature. Prove the functionality, prove the benefit, and then we've had scenarios where we're standard for an entire organization's testing process. Is that correct?
Yeah, that's pretty standard for us to do a pilot initial test. And when the client sees the results from that test, sees how well it went, how smoothly, and how much time and money they save. Several facilities now, we're going through and doing wholesale conversions from either manual procedures or CAPE, TSV, those type of things, over to TestDrive for the entire facility.
Specifically on conversion too, if you do have a lot of sunk cost, a lot of the times the sunk cost, you just can't consider it. You have to consider what the cost of your continual maintenance is. We can help you do some calculations to show that the return on investment is pretty quick.
Right. So you even had scenarios where we had clients with full manual procedures written. They had a full investment in one of our competitor softwares,
right,
and given the chance, it paid financial benefit to just simply redo those procedures in TestDrive and rebuild that simulation, right, and still came back as a savings to the client.
And we have experience converting either our competitors or manual procedures in, and we do that often.
And you can see time an engineering savings in doing that. So you're not starting from a blank slate. We can take advantage of what procedures are there and do a conversion.
Okay, excellent. So,
Got a question?
Sure.
From one of our customers, looks like, can we migrate a test drive application that was set up for one SIS vendor that is being updated to another SIS vendor?
Yes, definitely. So in most cases, the test procedure itself does not need to change if there's no logic changes. It's just swapping to a different communication driver. And as Brian mentioned earlier, you need to replace the tags with the tags in the new system. But from our perspective, the engineering cost is much lower for that. We can make that transition pretty easily.
Okay, good.
In fact, that would be a benefit for your FAT if you do have that situation coming up, because I'm assuming you're going to need to FAT the new system.